Hey there, let me show how to use pseudo registers in WinDBG. So, within WinDBG, there is a capability for WinDBG to remember certain variables when commands are run. These variables are known as pseudo registers. There are really a lot of pseudo registers that exist within WinDBG. I will put a link to this webpage in the description below so that you can get a list of all the pseudo registers. The registers are used together with other commands to aid in debugging. There are way too many to explain with just one video. So let me just show a demo of how to use two of these pseudo registers to learn the syntax. Let me switch over to WinDBG, which is waiting at the initial breakpoint. A pseudo register is basically a variable which has either the dollar or the $$ symbol as the prefix. How you can use the variable is you can either put it in a command or you can put it in a script. Let me show one of these variables, which is exentry. So let's just view that variable. If I put a question mark in the front, I can query the value of the variable. So it says that evaluate expression and it gives a memory address. This address is not so useful, but we can use it in commands. So let's just change that to BP. So BP is to set a breakpoint. What we're going to do is we're going to set a breakpoint, but the breakpoint is actually going to be located at the entry point of the executable. So let's just run the program and we can see the breakpoint hit exactly at the entry point of where this program starts. WinDBG is now stopped at the entry point of the executable. If I run K, I can actually see that the thread start and I can see the first function. That's just how you use pseudo registers. You put them into commands and they are just stand-ins for certain memory addresses or certain values that WinDBG knows. Let me show a more comprehensive example using exceptions. Let me resume the program. Now this program is running off screen. It's just a command line application in which I'm going to use to trigger exceptions. Okay, let me trigger an exception. There we are. An exception has been triggered from the application which is running off screen. Now you can see in WinDBG, there is no handler for this exception. So what has happened is WinDBG just ignores this exception and just writes a notification message. What I can do is I can actually just break into WinDBG. I can do SXE, put the code of the exception, run it again and trigger the exception one more time. And WinDBG will actually break into the exception. At this point, we can run all kinds of commands on the exception. But what if we just want to make a notification message that just has the exception code and the exception message? Well, there are a few pseudo registers that we can use. The first is EXR code, and that gives us the exception code. Well, we pretty much know the exception code from here, so let's go ahead and use other pseudo registers. If we use EXR numparams, we get the number of parameters in the exception. And each parameter is actually listed by its own name. So param0 gives us 0, which is the first parameter in the exception. Param1 gives us the next one, 2 gives us the next one, and 3 is the last in the list. So with this list, it's pretty confusing what it actually means. If we run kp, we can actually see that param1 over here, yeah, this is param1, is actually the same as the exception object over here. Now, if I try to view the exception object directly with DT, I will actually not get a value. That's because the exception object is declared as void. So WinDBG doesn't know what to do if I say DT with the parameter 1, which is actually this memory address. So to view the void pointer, I'm going to help WinDBG by just giving the parameter std exception. Now, I kind of know this because the throw in the program is actually just a standard exception. So if I tell WinDBG that I want to use the variable and I want to dereference with the @ symbol, that's why the @ symbol exists. If you put @ and $, it will dereference the variable. I can actually get the memory address of the variable and I can typecast it to std exception and I can get the actual memory address for the member variables of the exception. Let's look inside the data. So if I click on data, it's going to dereference data, which is 8 bytes. And we will get that the exception message is custom exception. So this is all fine, but can we script it? So let's give that a go. So we know that the data is 8 bytes from the parameter 1 of the exception object. So if I view that memory address, I can see that the memory address is exactly correct. And I can use this in my scripting. So let's go ahead and do that. I'm going to grab this line, which is the DX line. I'm going to put it over here. Then I'm going to swap in the variable instead of the memory address. Now, when I put the variable over here, what I need to do is I need to put a bracket and then I need to put an @ symbol because I need to dereference the variable and just close the bracket on the other side. And there we are. We get custom exception as the string. So this is exactly how you script it. Let's add it as the notification for this exception. So what I do is I just want to run sxe space, then I want to put -c, leave this command in the brackets, and then what I want to do is I want to just resume after that. So I want to get one line of the exception and I want to resume. Then I'm just going to put the exception over here. Let's run the application and trigger an exception. So when I trigger an exception, what I get is I just get the line custom exception coming out, and I've scripted WinDBG to a point that it does not need to stop at the exception. Rather, I just get the message coming out. If I trigger the exception multiple times, it becomes easy to see what the exception message is. And that is the power of pseudo registers. There are a lot of ways to use pseudo registers. That's just one of them. Generally, how pseudo registers are meant to help is that because they store a variable inside, you can use them in the scripting commands in order to find other memory addresses or find values which are difficult to figure out without the pseudo registers. I use the pseudo registers a lot in scripting, but there is another kind of pseudo register, which is the user provided pseudo register. I will use that in a different video because the user provided registers have a bit more syntax to them. So I think I'll make a video all about user provided pseudo registers in future. Let me know in the comments below if you have used pseudo registers before. And a gentle reminder to subscribe, hit that bell icon, and give a like if you like the content. As always, it's been a pleasure bringing you this information. I am High Voice, signing out.